Hey guys, today we are finally getting into quadratics. I'm so excited to finally start this unit. 11.1, we're talking about attributes of quadratics from graphs. So when I talk about this word quadratics, it's a quadratic equation. So we've been talking about linear equations, and in the word linear is the word line. So we've been talking about all kinds of lines, how to transform them, how to find slope, all that kinds of thing. Now we're moving into quadratics, which we've kind of touched on a little bit. The equation for this is y equals x squared. So this x squared, this little baby 2 right here, is what makes it a quadratic. And the graph for it, instead of a line, is called a parabola. It looks like parabola. It's pronounced parabola. And that's that big U. So we've kind of introduced it a little bit. And we've talked about standard form when we were doing factoring. That's all for quadratics. So I just want to start by talking some key attributes. So this first one has a graph of a parabola. That's what the graph is going to look like. So no longer linear. It's going to have a curve to it. It's going to look like a big U. And then you can face upward or it can face downward. The first thing I want to talk about is the x-axis and the x-intercepts. So our x-intercept is right here where it crosses the x-axis. Now remember, on a line, we only had one x-intercept. On a parabola, you can have one x-intercept, you can have two like we have here. It crosses the x-intercept twice. Again, we're looking to see where it crosses this line here. You can have 0. So there's 3 different types of them. So right here where it crosses that x-axis are our x-intercepts. X-intercepts. So that's the first part. Again, if you remember with SOX, SOX stands for solution, 0, and x-intercept. So if I ask for the zeros of the parabola or the solutions of the quadratic equation, I'm asking you for where does it cross the x-axis. Next, I want to talk about the y-intercept. That's where it's going to intercept the y-axis. So the opposite side over here, we're talking about this y-axis. So in our case, the y-intercept is right here. So that's where it crosses the y-axis. So this is our y-intercept. So nothing new so far, just different graph, but y'all have heard of x-intercept, y'all have heard of y-intercept, nothing new. These next things are the new part. So down here at the bottom of our U, we have this point right here. This is called the vertex. That's called the vertex. So that little point is called the vertex. Now notice here the parabola is facing up. The vertex is the lowest point. Over here we've got a vertex. It's the highest point because my parabola is facing down. So we have 2 different vertexes. We can have a minimum, which is this one. Oops, come here. Minimum. So that means it's the lowest point. Okay, that's as low as the graph goes. The rest of the graph is above that point. That's the minimum. Like if I were to draw a line right here, the graph would not go below that minimum point, that line. Okay, over here, this one, it's the vertex still, but it is going to be called a maximum. Because this is the highest point that the graph will go. If I were to draw a line here, the graph wouldn't cross it and go any higher. It's going low. The rest of the graph is going below it. So with the vertex, we have a min and a maximum. Min and a maximum. Okay. Then up here, we have something that's called the axis of symmetry. Axis of symmetry. And y'all have talked about this before, like in elementary school, y'all have heard of the axis of symmetry. Like if I folded a paper in half and it met, it would be symmetrical on both sides. And the way it's written is x equals a number. That's the way it's written. So in this case, when we have our axis of symmetry, it always goes through your vertex. So wherever your vertex is, you're just going to draw a line straight down the middle of your parabola through that vertex. So our line of symmetry would be that pink line. So if we said, for example, your vertex was over -2 down -3. If that was where the vertex was, to get your x equals a number for your axis of symmetry, you're looking at your x number. And in our case, our x number is -2. So the axis of symmetry would be x equals -2. Again, I got that from the vertex. Okay. I know, a lot of information, but again, you know x-intercept, you know y-intercept. The graph just looks a little bit different. We've got domain and range. Domain for quadratics is always, always, always let me find a different color here. -infinity to +infinity. Or you can say, if you want the fancy R, all real numbers. Always. That never ever changes. It's always going to be that. Never ever changes. And the reason for that is, notice the parabola has these arrows up here. Those arrows means it's going to keep going forever, out and out and out. So it's eventually going to reach all of the x values and all of the x values that are positive and negative. It's going to get them all. So that's why it's always that way. Even if I turn it upside down, it's still going out and going to eventually hit every single x value, negative and positive. So again, if it asks for a domain of a quadratic function, it's always -infinity to +infinity, or all real numbers. Okay, then your range. So when you have a minimum, like we have here, it's going to be y is greater than or equal to whatever your minimum is. Okay, in our case, our min was -3. So it would be y has to be greater than or equal to -3, because again, this is the lowest point. Everything else is going to go above it. And there's no top. Like the arrows say, they go on forever. So that's why everything has to be greater than the min. Another thing to remember is if your x squared term, whatever your x squared term is, where can we write this? I need more space. Sorry, I'm making you dizzy yet? If your x squared is positive x squared, your parabola is going to be facing up. Positive x squared, parabola is facing up. Okay, so on the flip side, if we came over here, I've got a parabola facing down. If you have a negative x squared, your parabola is going to be facing downward. So like something like y equals -x squared, for example. So that term, whatever number in front of it, if it's positive, it's going to be an open facing parabola. Negative, it's going to be a downward facing parabola. So that's how you know which is which. So again, I've got the x-intercepts. So again, I'm just looking, where does this graph cross the x-axis? So I have two solutions right there. Those are the x-intercepts. Again, where it crosses the x-axis. Same thing as the other one with the y-intercepts. It's where it crosses the y-axis. So in our case, it's going to cross right here. So that's our y-intercept. We only have one. We already labeled a vertex. This time it's the maximum because it's facing upward. And if I were to draw the line of symmetry, it would go right down there, down my vertex. Okay, so that is my axis of symmetry. Oops, go back. And again, it's x equals a number, and that number is whatever the vertex is. So if it's over -2, it's going to be x equals -2. Then again, we have domain and range. Domain, again, is always, no matter what, up, down, sideways, it is negative to positive infinity. And I guess not sideways, sorry. If it's up or down, it would be negative infinity to positive infinity, or all real numbers. Again, that's always for the quadratics. Your range is going to be, this time, y is less than or equal to whatever your maximum value is. So over here we had y is greater than, because everything was greater than that minimum point. Now everything has to be less than that max point right here, right? Nothing crosses that line. Okay, so those are kind of the, I know it's a lot, but that's kind of the attributes of quadratics. Those are the things that can happen. We talked about this earlier, but quadratics can have no solution, one solution, or two solutions. So remember with, what's it called? Linear functions, we could have one solution, no solution, or infinitely many solutions, right? So now we can have no, one, or two. No solution would look like this. We've got a parabola starting way up here, and this thing is never going to, never going to cross this x-axis line. Never. I mean, same thing, it could also be facing this way and going downward. Again, it's never going to cross the x-axis. Not going to happen. Okay, one solution is going to be, it's sitting directly on that line. It could be open this way, it could be open facing down. It could also be opened sideways, going that way, right? It's only touching it one time. So there's only one spot that it touches that red line. Two is like what we had on the front. So you've got a parabola either up or down, and there's two places where it crosses that red line. So again, no solution doesn't cross the x-axis. One solution crosses at one point, and usually it's your vertex that's touching it, right? That's the only spot that would happen. So if you want to write that down, vertex touches x-axis for that one. And then this one, two sides of your parabola touch for a 2. Okay, let's look at the parent function. So the parent function is what I wrote on the other side, the front page, was y equals x squared. Again, I look at my sign. Since this is a positive, there's not a negative sign in front of that x, my parabola is going to open facing up. It's going to be an upward facing parabola. Okay? Now, I would make a table of values to figure out how this thing's going to graph, how it's going to look. So we can plug in different x values to get y. So I say let's plug in like 0, 1, 2, -1, and -2. Okay, so if I plug in to this equation here, for the first one I've got y equals 0 squared, which is just 0, right? We got some lag going on. Just 0. Okay, 1 squared is 1. 2 squared is 4. -1, I've got -1 squared, which is -1 times -1, which is also +1. -2 times -2 is also +4. So if we were to graph all these points on here, 0, 0 is my first point. Then I'm going up 1 over 1, there's my next one. Over 2, up 1, 2, 3, 4 is my next point. There we go. Over -1, up 1. Over -2, up 4. So notice now when I go to connect my lines, I've made this U shape. That's what the parent function looks like. So again, y-intercept is where it crosses the y-axis. So it's crossing y and x right there at the origin. So my y-intercept is 0, 0. My vertex, remember either the lowest point or the highest point, that would be where it is at the origin, so 0, 0. Axis is symmetry, that's going to go through the vertex. It's that purple line, so our axis of symmetry is x equals 0. And again, we get that from this first here. It's always going to be that number. Those numbers are going to always be exactly the same. Maybe. That line cannot freak out. Okay. The quadratic parent function has how many solutions? That's how many times it crosses the x-axis. It only crosses one time. And again, that's because it crosses x-axis once. That's where we get that from. The x-intercept solution 0 of the function is 0. Again, that's where it crosses the x-axis. It crosses at 0. It's at the origin. Domain, again, -infinity to positive infinity. True for all quadratics. Domain is always -infinity to positive infinity. Then to get my range, it's a facing upwards, so it's going to be y is greater than, oops, yep, there we go. Y is greater than or equal to. So I'm looking at the vertex point. Well, it's not crossing this line here, right? That's the lowest point. So it's got to be greater than or equal to 0. So there's some of the attributes from looking at a graph. How are we feeling so far? Okay, let's look at example 1. So first off, it asks for the vertex. So I'm looking at either the lowest point or highest point. It's facing down, so it's going to be here. That's my vertex. So it's over 3, up 4. Over 3, up 4. And I know that this is going to be a maximum, because I know my parabola is facing downward. And when it's facing down, it's a max. That's the max point it's going to be. Axis of symmetry is what goes through that vertex. So if I were to fold it in half, it would fold on that vertex. So the axis of symmetry would be X equals, that's always that. To get the number, you're always going to look at whatever your vertex, your X was. So in this case, it's X equals 3. Okay, domain is always, 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 no matter what, negative infinity to positive infinity. Or you can write all real numbers. Range is going to be y equals, it's a max, so everything has to be less than or equal to whatever this y value is. 4. Everything's less than or equal to that 4. Okay, then we're on to y-intercept. So that's where it crosses the y-axis. And it looks like it's crossing right here. Kind of hard to see, but there it is. Y-intercept would be over 0, down -5. X-intercepts, again, that's where our solutions, that's where it's crossing this x-axis. And we have 2 solutions this time. So the first one, I'm going over 5, up 0, and over -3, up 0. Okay, zeros. These 2 things are always the same. It's asking the same thing. Same thing. So literally I'm writing the same answer here. 5, 0, and -3, 0. X-intercept 0 solutions. Asking the same thing. Max or min, again, we already discussed. This is a max at y equals 4. Again, that's where it stops right here at that 4. So that's how we know that. And that's how you tell the attributes from a graph. Pretty cool, huh? So let's look at number next. Okay, this time we've got our parabola. It is facing up, upward, right? So I know I have a min, a minimum. The vertex is going to be this lowest point right here, and that's over -1, up 1. Our axis of symmetry is going to go right through that vertex. And that's going to be y equals whatever this first number is, which is -1. Okay, then I've got domain. Domain is always negative infinity to positive infinity. Range is y, so y, it's a min, so everything has to be greater than or equal to this value here, which is 1. Y-intercept, it's where it's crossing the y-axis. And it is crossing the y-axis right here. There we go. And that is 2. So over 0, up 2. X-intercepts. Notice here's my x-axis. Maybe a different color. That's my x-axis, and the graph isn't touching it, so there are none. So you would just write none. And again, those 2 are the same thing, so I'm writing none. These 2 should always be the same. X-intercept 0 is the same thing. We already talked about this. There is a min. And the minimum point is at y equals 1. It's not going to go lower than right there at y equals 1. And I think that's it. Is that it? Yep, that's it. So just looking and seeing from graphs, x-intercept, y-intercept, you already know. Domain is always negative infinity to positive infinity. Vertex, axis of symmetry, all that stuff is new. So that would be the new stuff, and maximum, minimum. But for the most part, y'all already kind of knew a lot of it. So hopefully you learned something. I'm excited for this next unit. I think it's going to be really fun. Bye, y'all.